All right, good morning. Welcome to math class today. Today we are moving on in our understanding of fractions. So far, I want you all in class to tell me as many of the key words or things we've learned about fractions as you can remember. And I know we do have some helpful things up on the walls. So think back, what have we been working on with fractions? Angie, give me one.
Improper fractions.
Improper fractions. Okay, someone else tell me what that is. What is an improper? Hayden?
An improper fraction is basically not the right fraction. It's basically like a fraction that has a higher number on the top.
Yes.
And there's also a numerator and a denominator.
Okay, we've learned numerator, denominator, and you're right. An improper fraction, the numerator is bigger than the denominator, which makes it look kind of funny. Have we worked on anything else? Josiah?
Equivalent fraction.
Equivalent, which just means they are equal. They share the same amount. So, nice job, you remembered. We're moving on today to a very basic how to compare fractions by looking at pictures, okay? Next week, we will learn how to compare fractions without using pictures. But for today, we're going to start with this beautiful granola bar to walk us through how this works, okay? All right, I need a reader to read this top little part and then go ahead and read us the problem. Josiah, nice and loud.
In the past, you learned how to compare fractions using models. Take a look at this problem.
It's Adriana.
Adriana and June have granola bars that are the same size. Adriana ate 2/4 of her granola bar. June ate 2/5 of her granola bar. Which girl ate more of her granola bar?
Okay, so first just look. All right, Adriana's granola bar. First of all, I don't know anyone who wouldn't eat the entire granola bar. It's not like they're that big. But anyway, that was just my thinking. And June ate this much. Now, just by looking, before we even think it through, which girl do you think ate more granola bar? Liam? You're hungry. I know, it happens talking about granola bars. We'll have snacks soon. Angie, what do you think?
So first it
Teachers, one interruption. If you would do us a huge favor, I need you to have your lunch.
All right, we are back. We had an interruption from the announcements. All right, Angie was about to tell us, based on just what we read in the picture, which girl ate more granola bar?
First it said Adriana ate 2/4 and then June ate 2/5, and then on the bars it looks like Adriana ate more.
Okay.
That's kind of confusing.
It is a little confusing, but when you look at the picture, and I can even dot this line across, and you can look in your book, does it look like she ate a little bit more?
Yeah.
Yeah, it does.
But I think it's because her granola bar is bigger.
Okay.
It's like a little taller.
There's something different going on. Abby?
They were showing them who ate them. They this is the granola bar that's left, probably.
Okay, so they ate this much. Okay, so I see what you're saying. So you're saying the girl that ate the most would be June, because that part's missing. Okay. Now, the hard, tricky part about this, are the granola bars split up into the same amount of pieces?
No.
Is that what makes this so hard?
Yes.
It is, okay? So let's talk about this a bit. On A, how many equal pieces of granola bar did Adriana eat? How many did she eat? Remember, those are the ones that look grayed out. They're in her tummy now. Josiah.
2.
She ate 2. How many equal pieces of granola bar did June eat? Zoe?
3.
Whoa, whoa, whoa. Oh, yep, she did, sorry. I was already looking at this again. Since both girls ate the same number of pieces.
Huh?
No, they didn't.
Oh, you guys know what? This picture's terrible. They told us up here, the part they ate is the part that still looks granola-like. This is a confusing picture. So we were right to begin with, but it does look like this is the part that's been eaten. So the part that they ate is the part that's colored, okay? So let's restart our thinking. So using that as how we're considering this, how many pieces did Adriana eat? Zoe? 2. And how many pieces did June eat? Josiah?
2.
2. Since both girls ate the same number of pieces, what can we look at to find who ate more granola bar? The numerators are the same, so what do we have to look at? Liam, what do you think?
Just to clarify, I need today's lunch and Monday's breakfast. I don't need Monday's lunch. Just
Thank
today's
you.
lunch. Thanks.
I wasn't ready mine yet.
Okay. Cadence, what do you think? If we can't look at the numerator, what do we have to look at? The denominator. So on your page, we can just write denominator. I've got to scroll my page up while you finish writing that down.
Can I read the next one?
Okay. So I had this was a 2. I'm just going to rewrite it, and this was the denominator. All right, D. Hayden, go for it.
What does the size of the denominator tell you about the size of the pieces of granola bar?
Okay. We've talked about this before, but let's just take a look at this. Okay, this is one whole thing, right?
Yeah.
Agreed? Okay. Now I'm going to split that one whole thing into 2 pieces that equal one whole thing. Now let's split that one whole thing into 4 pieces and see what happens.
Still equal.
Okay. Did my denominator get bigger?
Yeah.
But what happened to the size of my pieces? Think it through. Quentin, what do you think?
It got smaller.
Yeah, as my denominator gets bigger, my pieces get smaller. We can even go littler than that. Look at these 8s. Okay, they're even smaller. Okay, so a 2, that's not a very big number. The pieces are large. A 4, it's a little bit bigger. The pieces are getting smaller. 8, the denominator number is bigger, but the pieces are still getting smaller.
And
Look at my 12. Look how little this piece is. So what pattern do you notice with our denominators? Abby?
it gets smaller when the denominator gets bigger.
When the denominator is a larger number, our pieces are getting smaller, right? Because if we're splitting them up into 12 pieces, I need a whole bunch more of them to equal one whole. So let's slide this over and think about our question. What does the size of the denominator tell you about the size of the pieces of the granola bar? Josiah?
So if it's less, it's gonna be bigger, and if it's bigger, it's gonna be the pieces are gonna be smaller. So 2 is it? Adriana ate more.
Okay, so we'll get to this second, but you're right. Let's talk about this first. So we'll say when your denominator, and I'll let you put DEN period, okay? We write it out sometimes to practice, but it's a long word. When your denominator is small, your pieces are bigger.
Can you say your pieces get smaller?
No, the pieces, when your denominator is big, when your denominator number is small, like a 2, your pieces are big, right? It doesn't take as many to equal one whole thing. So make sure you let that sink into your brain. If you have a small number in your denominator, you don't have very many pieces to make up one whole thing. But when your denominator gets bigger, and we can say DEN again.
Den?
Yep. So as your denominator gets bigger, the pieces get smaller. So you have to memorize that. So if you have a small number as your denominator, you can think, well, my pieces are really big. I don't have a whole lot of pieces to make my whole. But if my denominator, let's just say this. What if my denominator was 100? Do I have a lot of pieces making up my whole thing?
Now they would be.
They'd be tiny, right? I would have 100 tiny pieces to make up my whole.
That.
So if I had 1/100th and I'm comparing it to 1/10, which one of those things do you think would be bigger? 1/100th or 1/10? Hayden, what do you think?
1/10.
Yeah, because its denominator is so much smaller, right? Its piece is bigger. So you really have to let your brain think that through. It's kind of the opposite of what you'd think. Okay, so finally, E. Who ate more? Who ate more? Now remember what we said. When your denominator is small, your pieces are bigger. So they both ate 2 pieces, but whose pieces were bigger? Abby?
Adriana's was bigger.
Yep.
Because the pieces were big.
Yeah. June's granola bar was split into 5 pieces, and she had 2. Adriana's granola bar was split up into 4 pieces, and she had 2. So her pieces were bigger. She ate more. Who ate more? Adriana ate more. Make sure you're writing with me. Ate more because her 2 pieces were bigger. And I'm actually going to say we're bigger than June's 2 pieces. Well, we're finishing that up. Does anyone have any questions or anything that your brain's not quite connecting yet about this idea? We'll keep working on it, but if you forget, just picture these pieces, right? When I have the 1/2 pieces, they're huge. When I have the 1/12 pieces, they're itty bitty. All right, I've got to scroll my page up. You guys are going to just turn your head to the next side, 177. All right, now this page does have a lot of writing on it. So I will read some of it and just explain some of it. Make sure you're following along. All right. Deciding who ate most of her granola bar means comparing the fractions 2/4 and 2/5. Does anyone remember when we compared regular numbers, what signs did we use to compare them? We had 3 different signs we would use, and a lot of times we turned them into alligators. Cadence? Yep, remember these things? Greater than, less than, equal to. We're going to start using these again, but we're comparing fractions. So we will look at fractions, part of a whole thing, and decide which fraction's bigger or smaller. So this is what we're going to start working on. So you're going to start seeing these symbols again. Okay, so let's review. Let's just do the numbers 1 and 10, just to practice. If I wanted to compare those numbers, which one's bigger? Hayden?
1. No, 10.
10's bigger, right? So how do I draw my sign to show that? Which way does the opening open towards? Josiah?
The 10.
The 10. So your alligator mouth always eats the larger number, right? So we draw him like this sometimes. Right? He eats the bigger thing. Same with fractions. Your fraction wants to munch the big, or your alligator munches the bigger fraction. So here are our granola bars again. They don't look as tasty anymore. They took away the pictures. But look, they said 2/4 is greater than 2/5, which is exactly what we had just said. And on this side, let's see, they just reversed the 2 columns, and we would flip our sign because 2/4 is bigger. If the granola bars were not the same size, you could not compare the fractions to know who ate more. Okay, I wanted to say that one more time. Everybody listen. If your granola bars are not the same size, you can't compare their fractions. Why do you think that is? Let's think that through, because that's important. Hayden, what do you think?
We're not the same size. Well, if they weren't the same size and June's side was smaller and Adriana's was bigger, Adriana would have eaten less.
Well, out of total granola bar, if both girls ate the entire granola bar, would this girl have eaten more granola bar? But on these, they were the exact same size, right? So if they both ate the entire granola bar, it was the same amount of granola in total. Down here, okay? Even if she ate the whole thing, she could never eat as much as this girl. So when you compare fractions, it has to be fractions that are the same size. Does that make sense? Okay. All right, I've got to scroll down one more time. We've got a reflection question at the very bottom. Okay. Now we got to think this through. Explain how you can tell which fraction is greater. And I'm going to rewrite them large here so we can see them. 2/5 or 3/10. I'm just going to have you think for a minute. Think about everything we've just learned. The first thing my brain thought was, well, I know we learned something about denominators. And I know that when my denominator number gets bigger, my pieces are getting a lot smaller, right? And I know since this is a 5, are these pieces going to be larger? Could we draw a picture to look at this? Yeah. Because tomorrow, not tomorrow, we don't have school tomorrow. When we come back, we're going to learn another trick about how to find fractions with the same denominator. But for today, let's draw a picture. So I need you to draw a rectangle. Doesn't have to be perfect, just a rectangle. All right, once you've got your rectangle drawn, let's split it up into 5 equal pieces, best you can, okay? 5 pieces. All right, in our fraction that has a denominator of 5, how many are in our numerator? How many do I need to shade in? I'm about to call some victims. If you know and you're not raising your hand, raise your hand. I like to have a lot of people answering. Of my fifths, how many do I need to shade in? Quentin?
2.
2. Thank you. So shade in 2, best you can. All right. Now how can I change this easily to have 10 equal pieces? Abby?
You make a line and through the...
Right through the center?
Right through the center.
Yes. I'm going to switch colors so you can all see it. So now everybody, go ahead. Sometimes I make it a dotted line so I can tell that it's my second split, but it's kind of your preference. So now let's count and make sure that we have 10 even spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We did that right. So now we can look. Okay, 2/5 would be 4/10, right? Is that bigger or smaller than 3/10? Is it bigger or smaller than 3/10? There's about 4 or 5 of you that I know have it because you've been answering all the questions. You're very into the lesson. This is not a hard question. Let me say it again. When we had 2/5, that's all the orange here. When I made it into tenths, now that is 1, 2, 3, 4 tenths. So, is 2/5 bigger than or smaller than 3/10? Liam?
The same.
It's not the same. If I had 3/10, I'd have to take one of these away, right? So is 4/10 bigger?
Yeah.
Yeah, 4/10 is a little bit bigger than 3/10. So that means 2/5 is bigger than 3/10. Now I know comparing like that is hard. Okay, it is hard. It's hard to reason through. I always remembered when I did it with my teacher, it always made sense then, but then when I had to go do it by myself, it was like, what? So take a deep breath. When we come back next week, you see there's some more math tricks here. We can use multiplication and do some extra stuff. I will teach you a trick so that you can have the same denominator. Is it easier to compare fractions when the denominator are the same?
Yeah.
It's way easier. So next week, that's what we're going to work on, okay? So you don't have to draw these pictures every time you do a problem. All right, any questions for me before we wrap this up? Hayden?
Can you show them your button?
My button. Oh. All right. I got a button for Christmas, and since a lot of people get stressed about fractions, anytime you're feeling stressed, you can push this.
You got this.
So, all of you at home,
You got this.
and with that, I'll see you tomorrow.
Bye-bye.
That was
Whoop.